Hey guys, here is the basic idea behind how to figure out volume when doing integration. So we'll start out with something simple. I know some of you saw this yesterday, but not everybody got a chance to see it. So I'll just do the basics here and see where it goes. So let's start with y equals x, and we can go to 5, let's say. And you guys would have no trouble calculating the area of this region from 0 to 5. That would be obvious. In fact, you could just use geometry to get it. But the idea that I want to go today is I want to take this region and revolve it around the x-axis. So I want to literally take this and revolve it around, creating a solid. Now, if you can sort of picture that, if I revolve this around, you basically get what appears to be a cone. Okay, so take this region, revolve it around the x-axis, and keep revolving, keep revolving, keep revolving, and you'll get a solid that looks like a cone. Okay, now when we did area in the first place, we would break everything up into little rectangles. But in this case, if I were to cut this down, I wouldn't get a rectangle. If I slice through, get like a little cross section here, I would get a circle. Okay, in fact, it's really the same kind of idea that's on the bottom. You'd have a circle. You slice through anywhere, you're going to get a circle. You can get a little tiny circle over here, you can get a bigger circle here, etc. So let's just focus in on this one sort of generic circle at the moment. That circle would have a radius, okay? And it's if it's just a circle, it's two-dimensional. I need something three-dimensional. So it needs to have a little bit of depth, just the tiniest little bit. So this circle with just a little bit of depth actually becomes, a little cylinder, just a little tiny cylinder, even though it's, I know it's a little slanted, but let's pretend that that delta x here, this depth, is really, really small. Okay? So if this delta x is really, really small, you have a really, really, really tiny cylinder here. And if we take and add up all of those little cylinders, all those slices, we will get the volume of the entire cone. So we don't have to do the sigma version because we already know that the sigma version directly connects us to the integral. So I can set up an integral from a to b, so in this case from 0 to 5, of the volume of this one cylinder, add it all up, an infinite amount of them. The volume of this one cylinder would be, volume of a cylinder, right, is just big B times h. Well, big B is pi r squared, because that's the surface area of the bottom, or the top, I guess, if it's a cylinder, right, times the height, okay, or the depth in this case. So pi r squared times the depth, which is delta x. Well, let's clean that up a little bit. The radius, we know. The radius is whatever the value of the function is, right? So it's really, here, I'll even do one more step. It's really f of x squared. R becomes f of x, because whatever the function is determines what that radius is. If I was over here, the radius would be up there. If I was here, the radius would be all the way at the end. If I was here, it'd be down there. Whatever the value of the function is the radius. Just like whatever the value of the function is was the height of the rectangle when we did rectangles. Times, right, this is big B, times h. Well, h is the depth, that's the delta x, which is dx. F of x we know is x. So this is 0 to 5 of pi x squared dx. We can integrate this. So that's going to be pi x to the third over 3 from 0 to 5, which is 125 thirds pi. Okay, let's go old school geometry. The volume of a cone in geometry is 1/3 big B times h. Right? Remember, those of you that had me, remember when we filled up the box? We filled up the cone and then saw how many times it took to fill up the box from the cone. It was 3 times. So we did 1/3 big B times h. So this is 1/3 pi r squared times h. 1/3. The radius of the cone itself is 5, right? This is 5, 5. So that's going to be 5 squared times the height of the cone, which is actually this way, but it's still, I just happen to pick 5 arbitrarily. 5 squared times 5 is 125 divided by 3 times pi, same thing. So here's the main idea. You take whatever the function is. What I would do is, what I would recommend is you would actually draw its reflection so you can see what it would look like revolved. Draw yourself a sample disk Find the radius, which is basically the function, and this basically will do it for you. The volume is going to be from A to B, pi f of x squared, which is basically the radius, dx. Okay, where f of x, this is the radius. And this is the foundation that everything's going to be built on. A lot of times you might see the pi out in front, right? And you might even still see, it might just say r squared. But you get the idea. They basically, sorry, that b got messed up there. That's just a to b. The concept is the same. It's still just the volume of a disk. Pi r squared delta x. Okay, this part's just the circle, and that's just the radius. So when we did area, we said it's just basically rectangles. When we do volume, it's basically disks. Okay, now they're going to get a little more complicated, but this should get you through. Actually, you probably could do a decent chunk with just this knowledge right here. But I'm going to keep going. I'm going to do more of them. Some of them have little twists and turns, which I'll do in a couple more videos coming up. Okay, please let me know if you have any questions. Hopefully this will get you started, and I will talk to you guys later.